this slide is feasible to all of you, right?
Yes, sir.
Okay.
Yes, sir.
Yeah.
Yes, sir.
Later on, I can share these two PDF to you or to Shajul sir. Then he may forward to you in your group maybe. So there are so many things available in the slide, but everything you need not to study. So I'll just guide you exactly which portion is needed for you. Okay. So
Okay, sir.
people are waiting in the lobby. So let them add. Samim is there. Fine. So the basic things are like I'll just very simply talk about the MOS and directly go to the CMOS, and I'll discuss in brief its advantage. Okay. So I'll just you may not note down the slides which are mainly important. Not every slides are important. So this slide is basically uh, covers so many things. So I'll tell you which part is needed only for this. Okay. Okay. So let's start with the slide number 3. So the name of the device which is commonly used for all the digital circuits nowadays for the digital ICs, uh, that is known as the MOSFET, MOSFET. So MOS actually stands for the metal oxide and semiconductor. Okay. So MOS, it's an abbreviation of metal oxide and semiconductor. So it is a 3-layer sandwich structure, and it is a type of transistor just like the PNP and NPN transistors which you may have studied at the 12th standard. So those who have studied, those who have they are having a science background may have studied in physics, in modern physics, right? So that type of transistors are NPN or PNP type. Two types are usually or commonly available, and this type of device is known as the field effect transistor. Field means these transistors are operated with the help of electrical signal. So that electrical signal or the voltage is here defined as the field. So that's why the name is the field effect transistor. Briefly, the FET, the MOSFET, is classified into two categories. One is the PMOS. P stands for the positive and NMOS stands for the negative MOS. So the symbols for the PMOS and NMOS which are available here, I think you can find that this is available here, right? So this is the basically the structure of this NMOS and the PMOS. So here you will find there are 3 terminals. Can you see that? For both PMOS and NMOS, the device, so there is a bubble and there is a terminal which is known as a gate. Okay. So there is a gate terminal and there is a bubble terminal, right? So this bubble is connected to the gate, and the electrode or the terminal where you will find there is an arrow. You can find that. Okay. So that arrow is basically the drain terminal, and the other one as the source terminal. The bottommost channel electrode is known as the source terminal. So just like the transistor NPN and PNP, there are 3 electrodes or 3 terminals which are known as like the emitter, base, and the collector. So those who are from science background, again I'm saying emitter, base, and collector. Just like here, it is the gate terminal which is having a bubble, right? And there is another one which is known as the drain. The upper one where the arrow is associated, that is the drain, and another one is the source terminal. So gate, drain, and source. So in PMOS you can find there is a bubble. So it is basically operated in a inverted logic, and for NMOS there is no bubble. Okay. So this is you should know the basic symbols. So these are the symbols for the transistor for PMOS and NMOS. Now for these transistors, basically you will find, okay, someone is waiting in the lobby. Let them add. Okay, that's fine. So it's basically that whenever the device is connected to the power supply. The gate actually controls the flow of current from the drain to the source, from top to the bottom. Okay. So from top to the bottom, this is control like this. So I think you can follow my pointer, right? So the pointer shows that, just a minute. So may I change the pointer? Not like that. Whatever. Just a minute. Fine. So the current flows from the drain to the source like vertically, okay, up and down. So, and this gate terminal, the purpose of the gate terminal is only to control the flow of current, right, from the drain to source. So this is the symbol for PMOS and this is the symbol for NOS, right? So this is basically acts as a switch. The gate terminal acts as a switch, and we apply a voltage to the gate terminal, which controls the flow of current from the drain to the source terminal, and the switch is just like on and off. Okay. So now quickly go to the, so you'll note, I think you have noted down the slide 3. Skip the slide 4. This is not needed for you. So the detailed characteristics is not needed. Right. So now come to the slide number 5. So I can find that these devices, whether NMOS or PMOS, they can be used as a resistor or they can be used as a switch. Now, you just see that on the left-hand side, so there are 3 terminals. So one is the source. Okay, so this is the drain, this is the source, and this is the gate terminal. Now, here the source where the pointer, where there is an arrow, that is grounded. So you can find that in the source, it is grounded. Can you see that? Source is grounded for NMOS type of devices. And in that case, and the gate, when it is ground, the circuit is off. And when the gate is connected to the power supply VDD, the device is on, right? So just what is happening over there, follow me. This is the drain terminal. Follow my pointer, right? So this is the drain terminal and this is the source terminal, right? So the current flows from drain towards the source like vertically down, like this. And here it is the gate terminal. Now, generally the source is always grounded, just like this. So have a look. The source is grounded. So this is the equivalent circuit of the transistor on the right hand side. It is just like a resistor and it is behaved like a switch, on and off, close and off, switch like this. So the source is grounded. This point is always grounded and drain is connected to the power supply. Power supply, it is denoted by VDD. So DD stands for the drain power supply. So you can find VDD is written over there. DD stands for the drain power supply. It is approximately its value like plus 5 volt, plus 6 volt, or sometimes plus 10 volt or 15 volt, like this DC power supply. So the transistors are always operated with the DC power supply, and its value may be varying between 5 volt, 10 volts, 15 volts, like that. And however, at the gate terminal, you just see that this is the gate terminal. This is for the NMOS device. So for the gate terminal, you just see when the gate is ground, gate is connected to the 0 volt. Ground means the 0 voltage, means the gate is off. No signal is applied to the gate. No voltage is applied to the gate terminal. In that, okay, so in that case, the device is off. Okay, so in that case, the device is off, right? And when the gate is connected to some high voltage, like the VDD plus 5 voltage, means when we apply an electrical signal to the gate terminal, like here, so the device is on. Okay, so for NMOS device, in a single line, you just note that when you just make a note for this. For NMOS, the source is always grounded. I hope you are noting it down, right? Write down. So the source is usually grounded for NMOS device, and the drain terminal, this one is right here, drain, and you write here source. So the drain terminal is connected to the power supply VDD, and the gate may be low or high. So low means ground voltage and high means the VDD. Note down. So when the gate voltage is low, low means ground, 0 volt maybe. So the device is off. So what does it mean by the device is off? There is no current flowing between drain and the source terminal vertically. So in this vertical path, no current is flowing. Can you see that? So no current is flowing from here to here. Okay. So follow my pointer from down from the drain towards the source in this vertical path, no current flows when the gate is grounded. Means we have not applied any voltage to the gate terminal and the device is off. So as no current is flowing, so we say the device is off. Second case, when we apply a high voltage, just see that for the gate terminal, when we apply high voltage like VDD, so like plus 5 volt we apply to the gate terminal, the NMOS device is on, right? So you just note this particular part. You just note down this particular part. NMOS source is grounded, drain is connected to VDD, and two different cases arising. When gate is ground, that is low. Low means binary 0, is logically 0. So when at the gate, the voltage is low or ground, the NMOS, the device is off. And secondly, right, when the gate voltage is high, like VDD means logically high or binary 1. Okay, so in that case, the device is on like this. Okay, so have you noted down, all of you? So you need to draw this part only, this particular symbol and only this part, and whatever I have said. So this is about the NMOS. So what is the learning outcome from this particular slide number 5? Here for any NMOS device, when we apply low voltage to the gate terminal, the device does not conduct. The device is off. And when we apply a high voltage to the gate terminal or binary 1, the device is on. Is that clear?
Yes,
Have
sir.
you understood?
Yes, sir.
Yes, sir.
Fine?
Yes, sir.
Yes.
Okay. So this graph, IDS versus VDS, is not needed for you. Okay. So only this part, whatever I tell you, that much you should note down. I'm going to the next slide.
Sir.
You can skip this one. Yeah, any query?
Sir, বৈষম্যটা input and output characteristic পড়তে লাগবে না তাহলে?
না না, ইনপুট এন্ড আউটপুট ক্যারেক্টারিস্টিক্সটা পড়তে হবে না তোমাদের, অত
Okay, sir.
ডিটেইলস তোমাদের এখানে নেই, বিকজ those electronic students are studying that part because they have to study the device characteristics, but here only you need to know the application part only. Okay, so you need not to go into the physics of this input and output characteristics, so you can skip that one. Okay, fine. So this is the physics part of that. It's not needed, you can skip this. Okay, now we are directly coming to the PMOS. Note down slide number 9. Quickly draw this symbol, this one. Okay, draw this particular symbol, that is the symbol for PMOS. Okay, and then write the description for this. Here we just see that here it is written NMOS, it is wrong. Here it should be PMOS. Have you noted that?
Yes, sir.
Yeah, so here it is wrong. Here you write it is a PMOS device, and the symbol of the PMOS device is just like this. So there is a bubble for PMOS device. So follow my pointer. Okay, again we can find for the PMOS device there will be the source, drain, and the gate terminal. So this is the gate terminal. Okay, This is the gate terminal. This one is the drain terminal, and the arrow, this arrow is associated. This terminal is known as the source terminal. You just have a look that for the PMOS device, this arrow is entering the device, right? So it is an inward arrow. Have you noted that? So the arrow is entering the device. Now I'm going to the symbol for the NMOS. Can you see that for symbol of NMOS? Here the device is, here the direction of the arrow is outward, isn't it? So this is how we identify that when the arrow is outward, that is an NMOS device. And in that case, when the device is, when the arrow is incoming, in that case, the device is PMOS. Now you just note down this part only. Here you write PMOS. The characteristics of PMOS is what? The source is connected to the VDD. Note down. The source is connected to the VDD. এখানে opposite কিন্তু আগে কি ছিল? In the previous case, the source was connected to also VDD, but এখানে দেখো for NMOS, the source is connected to where?
The ground.
Ground. So in a single page, তোমরা পাশাপাশি দুটো লেখো side by side so that you can easily understand. So for NMOS, the source is connected to ground, and when the gate is low, ground মানে হচ্ছে when the gate voltage is low, the device is off, and when the gate is high, means the binary 1, logically high, the device is on. So this is for NMOS. Now coming back to PMOS. So দেখো PMOS এ কি বলছে? For PMOS, the source is connected to VDD. Okay? And when the gate voltage is equal to ground, ground means low voltage. Note down. So when the gate voltage is ground or low, means binary 0, logically 0, then the device is on. Note down. And obviously, when the gate voltage is high, high means it is connected to power supply, VDD. So the VDD value may be plus 5 volt, 10 volt, or 15 volt, 20 volt, whatever. That is a DC power supply, DC voltage. Okay, so you just see that when the gate voltage is low, the device is on. It is just opposite to that of NMOS. Am I right? And when the gate voltage is high, means the gate equals to VDD or plus 5 volt or binary 1 or logically 1. In that case, the device is off. Have you noted down? So
Yes, sir.
you just
Yes, sir.
yeah.
Yes, sir.
So, you also note this symbol. Here the symbol is different. Here there is a bubble which is associated to the gate terminal. Okay, and there is an arrow which is inward. However, for NMOS, the arrow is outward. Okay, and here the source is connected to VDD, that is the power supply, and in the NMOS, the source is connected to ground. Is that clear? The difference between two types of devices? Apart from this, the detailed physics is not needed, only the basic application part. So have you noted down?
Yes, sir.
Yes, sir.
Fine. Okay. So now once we understand the configuration of PMOS and NMOS, then I'll go for the combination of both. So now in a single page, you can see the comparison is given. Okay. You can take a screenshot or পরে আমি এটা যদিও VTF টা দিয়ে দেবো, but in a single page, the difference is very, very clear. So for PMOS, okay, the source is connected to VDD, and NMOS it is opposite. Clear? So I request all of
Yes,
you
sir.
to
Very clear.
yeah. So you may be already noted down. However, if you have not, you can just write it quickly. You should note down the symbol, and also you should note down the behavior. Now just see the title of the slide. It is like NMOS and PMOS, they are having a complementary behavior, isn't it? Right? So they are having a
Yes, sir.
complementary behavior. So in PMOS,
Yeah.
the source is connected to power supply, whereas in NMOS, it is opposite. In PMOS, when the gate voltage is low, the device is on, whereas in case of NMOS, when the gate voltage is high, VDD, then it is on. So it is exactly opposite in terms of behavior, in terms of the on-off state. Okay? That's why this type of complementary behavior of MOS and uh, and connection between this PMOS and NMOS together produces a new device, and that new device is nothing but known as the CMOS, and C stands for the complementary MOS. Okay, so after this slide we can just simply have a connection just like this. Okay, so now you do one thing. I'm going back. I hope you have already noted down the symbol for PMOS and NMOS. Okay, now you draw these two symbols. On the top you draw PMOS, on the bottom you draw NMOS. Okay, draw this. Draw the PMOS on the top, and at the bottom draw the NMOS like this, exactly in this manner, in this particular slide. Do you follow me? So
Yes,
now,
sir. Yes,
yeah.
sir.
So now for PMOS, this upper terminal is the source. Can you see that this is the source terminal, and where it is connected to the power supply, VDD. Okay. And for NMOS, this is the source terminal, right? So this source terminal, where it is connected to ground. So now we are joining these two transistors. Okay. So we're making a connection between the PMOS and NMOS. How exactly? Just like this. Follow this particular circuit. Can you see that? Now we can find we are having a composite device, and name of the device is known as the complementary MOS, the metal oxide semiconductor, CMOS device, where we are having two transistors connected together. How? Just see on the top there is PMOS, okay, and this is the source terminal of the PMOS, which is connected to where? VDD, isn't it? It is connected to VDD, whereas at the bottom there is an NMOS. So the NMOS, this is the source terminal, the arrow is coming out, so that is an NMOS device, and you know that for the NMOS device the source is connected to ground. Okay, so what we are doing, the source for PMOS is connected to VDD and the source for NMOS is connected to ground, and now we are joining the drain terminals of the PMOS and N terminals NMOS devices like this. Okay, so this is we are joining the both the drain terminals for PMOS and NMOS together, and also we are connecting the gate terminals for both the NMOS and PMOS to have a common input gate terminal. So this is the common input gate terminal for the CMOS. So whatever signal is applied here, this is connected to both the gate of the PMOS. This also goes to the gate of the NMOS also at the same time. Okay, and this whole structure is known as the complementary MOS, the complementary MOS. In short, it is known as the CMOS. Okay, so now every CMOS has got two parts. One part is on the top, that is the PMOS, and the bottom is known as the NMOS. Is it clear? Okay.
Yes, sir.
Now, yeah. So now let's have a study on this particular diagram. Let's say here the input IN, it is actually the input to the CMOS circuit, this entire CMOS circuit. Now we just think the entire circuit as a single entity, is a single device now. Okay. Now we are applying some input voltage. So this is the input terminal we apply to the gate of the common gate for both PMOS and NMOS, and the output is taken out from the common drain terminal like here. Okay. So this CMOS has got one single input, that is in, which is connected to the common gate, and the output is taken from the common drain for both the PMOS and NMOS. Okay. So now we understand that CMOS has a single input and single output. So where we apply the input for CMOS? The common gate. And where